Hello everyone. Today we are going to study about equations of projectile motion. Suppose that the projectile is launched with the velocity v0 that makes an angle theta naught with the x-axis. Let us see in the figure. Here v0 is taken as the initial velocity. Now let us talk about the acceleration. Acceleration acting on the projectile is due to the gravity which is directed vertically downward. Since the gravity is acting in the downward direction and we are representing here this gravity or this acceleration due to gravity in terms of unit vector, so we write here A is equal to minus g j cap, since the direction of j cap is along the y direction in upward side, so the g as it acting in downward direction, so it is given as with minus sign. Along the horizontal axis, if we talk about the x-axis, as there is no gravity, as there is no value of g along the x-axis, so acceleration along the x-axis will be taken as 0, while along the y-axis it is considered as minus g. The component of initial velocity v0 r in along the x-axis, it can be written as v0 cos theta naught, while along the y-axis it will taken as v0 sin theta naught. Now we will write the initial component of velocity along the x-axis and y-axis. If the initial position is taken as the origin O, then our equations of motion for the initial position is given by x0 is equal to 0 and y0 is equal to 0. So our basic equation of motion, second equation of motion becomes x is equal to x0 plus initial velocity t plus half axt square, as you know it very well. So we just put the value along the x-axis and obtain the result. Similarly, we get the value of distance or displacement along the y-axis in terms of given values. Now this component velocity after time t, if we want to calculate it, again we use the equation of motion, the first equation of motion which you give v is equal to u plus at, and in this case we took the initial velocity as vo. So along the x-axis we will write vx is equal to v0 cos x0, and along the y-axis we will write v0 sin theta naught minus gt. We just simply put the value of initial velocity component along the x-axis, along the y-axis, as well as the value of acceleration due to gravity along the x-axis and y-axis, and we get the pair of these equations. Now see in this figure, as the velocity changes continuously, so initial velocity is fixed for each and every point since it is the initial factor, so remains constant throughout the motion. But टाइम टू टाइम द फाइनल वेलोसिटी चेंजेस विद रिस्पेक्ट टू टाइम, जैसे जैसे टाइम बदलता जाएगा वेलोसिटी लगातार चेंज होती जाएगी. तो यहाँ पर हम लोगों ने कई जगह वेलोसिटीज़ के कंपोनेंट को स्प्लिट किया हुआ है along the x-axis as well as along the y-axis. If you see at the highest point, you see the whole component velocity is along the x-axis and there is no component of velocity along the y-axis. Since the velocity is given by the initial velocity, here you see v0 sin theta naught, and at the point where it becomes v0 sin theta naught minus gt, further it reaches at the maximum point and you see here the final velocity becomes along the completely x direction and the y component of this velocity becomes 0. Further it reaches towards the ground with changing in velocities. Now Note here, the horizontal component of velocity remains constant throughout the motion. Why it remains constant? Because this velocity doesn't affected by the acceleration due to gravity, since along the x direction no gravity acts and hence no force acts which is responsible for the velocity change. Vertical component, if we talk about the vertical component reduced to zero at its peak of the path and again increases in the opposite direction because of gravity. The magnitude of velocity of the projectile at any instant t is given by v naught square cos square theta plus v naught sin theta naught minus gt square का under root. The direction of velocity of the projectile at an instant is given by v naught sin theta naught minus gt upon v naught cos theta naught, as you see using the Pythagoras theorem. Now, equation of path of the parabola or projectile motion. The shape of the path of projectile can be found by mathematical equation, since now again we use some equations here to solve it. Since we know that the position or displacement along the x-axis is given by v naught cos theta naught into t, from this equation we have obtained the value of t, and y, the component of position along the y-axis. We choose the previous equation and just put the value of t which we have obtained earlier. And on simplification, we see that y is equal to tan theta naught x minus g upon 2 v naught cos theta naught square into x square. Now, since few parameters like g, theta naught and initial velocity v naught are constant in the above equation, so we can directly replace by a constant parameter factor a and b, and we get a simple form of equation y is equal to ax minus bx square, where a tan theta naught and b is equal to g upon 2 into v naught cos theta naught whole square. So the above equation is the equation of parabola. What is the equation of parabola? If the y component or y axis is directly proportional to the x square, then this equation is known as the parabola equation. And here we see that the y is equal to ax minus bx square is given. That means y is directly proportional to the x square also. So we say this equation or the path of the projectile is a parabolic path. So whenever it is asked in your examination that what is the path of the projectile motion, the answer is parabola. Why it is parabola? Because it follows the equation of parabola.